welcome back to Reviewed Chemistry. Today, we'll be looking at what? Covalent bonding. In our previous video, we looked at how to work on what? Electrovalent what? Bonding. But today, we're talking about the illustration as regards to what? Covalency. So what is covalent bonding? Covalent bonding is one of the strong bonds existing in what? In chemistry. And it is the equal sharing of electron between two what? Corresponding what? Atoms. So let's take an example of what? A hydrogen molecule existing in respect to what? Covalency. So formation of what? Hydrogen what? Molecules. Formation of hydrogen molecule. Now, remember in the periodic table, hydrogen occupies the first place as what? Atomic what? Number 1. In covalency, you work on the what? Their quantum shells. Covalency deals with what? The shells of each of the what? Electrons. So firstly, if you're working on the formation of hydrogen molecules, remember having here is diatomic, which means that what? You have what? One hydrogen and another what? Hydrogen existing in what? In covalency. And this is the bond separating the two of them. But here, you will use what we call quantum shells to illustrate it. In the quantum shell, we have what? K will take mass of 2 electrons. But in respect to hydrogen atom, we have in respect to that. So K here will be what? Will be existing as what? 1 electron. That is for K shell. And since it's what? 2 hydrogen atoms, so you have H is equals to 1 here, and here you have plus another shell, because you're working on what? 2 hydrogen atoms. So here is another what? K shell, and K here is what? Stand for what? For 1 electrons. Now, in their covalency, what you're going to do, these places will call this what? Incomplete what? Incomplete shell. And here is what? An incomplete shell again. Why are they incomplete shell? Remember that an atom is said to be stable when it is what? In a duplet state or what? In an octet state. At this moment, hydrogen, these 2 molecules of hydrogen are not in what? In a duplet state. Neither are they in what? In an octet state. So it becomes what? Unstable. And so you can say that they are what? Unstable. Unstable what? Elements. Now, let's do the bonding formation. It is very simple to do their equal sharing. All you have to do is what? You draw a shell. 2 shells will be close to what? Each other. How many electrons are here? This one is 1 and this one is what? 1. What you're going to do in their covalency, you just put 1 electron here, put another here. Here becomes what? Their equal sharing. So that when you count each of the shell, they will contain a duplet electron. That is 2. This shell means what? 1, 2 for this particular shell. And this shell means what? 1, 2. Which means it's 2 of the what? The 2 of them what? Stable. So this shell becomes what? Stable what? Shells. Or it can become what? A stable what? Electron. Or stable element. Thereby, we say that what? This is a complete what? A complete what? Shell. Because of what? Their duplet states. And which element is what? In a duplet state in the outermost shell in periodic table? The only electron or the only element that have that duplet state is helium. And helium is what? A noble gas, which is what? A stable what? Element. So whenever you perform formation of what? Covalency, it must take a form of stability of the next available what? Atom in the periodic table. I believe with this short video, you'll be able to illustrate in your own way using this example I've given to you, illustrating the formation of what? Chlorine molecule. Formation of what? Chlorine what? Molecule. which is what Cl what Cl2. Using the same this example I've given to you now, you can work on what formation of what chlorine molecules. See you in our next what video.